Screen. The topic, I spoke to one of your participants and she requested me to discuss on inferential statistics as part of this program. Yeah, I may not be able to do everything in this 1.5 hour, 1 hour 20 minutes, 1 hour 15 minutes, but let me try to give you some brief about inferential statistics. Otherwise, we are supposed to teach some 3 to 4 days on inferential statistics itself. So we have so much of information, so much of content. We can conduct a kind of a workshop on inferential statistics. So as far as my credentials are concerned, you can see my contact number is there. You can note down 9866699983. My mail ID is there. And some of you from management, social sciences would like to know about my research. Go to my homepage. That is there as www.profbrashekar.in, and currently I am working as a senior professor at the School of Management Studies, University of Hyderabad. Of course, my educational credentials are there. I did my BTech Civil, then moved to MBA, then PhD Management, then MSc Psychology, PhD Psychology, MA Education, PhD Education. So my recent degree is PhD in Education. So I have been into this management teaching for the last 30 years, 30. So I have been handling the course called Statistics and Research Methodology. Of course, there are a lot of various management subjects like operations research, operations management, supply chain management, project management. But of late, I have been mostly concentrating on statistics and research methodology. So as part of MOOCs, that Ministry of Education, that is MOOCs Swayam and Arpit. So I have developed 2 courses. One course is Research Methodology for Social Sciences. Second one is Data Analysis for Social Science Research. So these are the 2 courses I have offered through MOOCs of Swayam. So if somebody is interested, even still it is in offer, I think you can explore that possibility of doing it. There you get more details about data analysis tools, including inferential statistics. So this is just brief about me. Of course, Bellamakonda has introduced so many things, but just take my credentials, and I think there are many research scholars and a few assistant professors. So I would like to know from you one simple question before I start my session. So why do we do research? Any one of you? Why do we do research? Why do we do research?
Very good morning, sir.
Yes, please.
Sir, as per, sir, I would like to say in my words, sir, we encounter any problem in the society, and we are in urgent desire to solve that problem related to our subject or some interdisciplinary subject. So in order to solve that, we are in very limited situation how we would be able to solve it or cover it or anyhow deal with it. So that is the motive behind doing the research. But that's why we chase for research.
Okay, fine. So how is the whole world is going to know about your research? So you are doing research in Gulbarga University, Central University of Karnataka, or Mysore University, Karnataka University. How the whole world is going to know about your research?
So publication.
Publications. Okay, it's good. So then what is the challenge in having good publications? This is the next question. So why are we not able to publish good research papers as researchers, especially from social science discipline? From social science discipline, the biggest challenge is publishing papers. So you forget about Scopus, Web of Science, Science Citation Index, SCA and so on, and we are struggling to publish in CARE, UGC CARE list. So what is the problem in publishing papers, especially from scholars of social sciences and humanities?
The first problem, sir, I could think that we are poor in conceptualizing concepts and constructs. And second, we are not well equipped with the research methodology of different kinds. What kind of methodology we can apply to our researches, and we are unable to explore the variety of research methodology which can be applied to a single research.
Okay, fine. So now the biggest problem is, we have weak methodologies. This is the biggest problem. The second one is even the methodology is weak. The second part is our statistical treatment of data is not so great. Because majority of our social science teachers leave mathematics at 10th class. After 10th class, hardly they have touch in mathematics. But mathematics never leaves you. Either statistics or mathematics, that never leaves you. You may have to continue it till you do research. That's number one. Number two, articulation of the data interpretation. How you interpret the data, how you are going to articulate, and how you are going to build your argument. How you build your argument. So that is another important issue. The third important issue is review of literature. Sound. What is the quality of review of literature you are referring to? And also the kind of journals which you are citing in your research. These are all kind of issues, but I am not getting into too many things. Otherwise, ideally I handle 15 days of research methodology from morning to evening, cover everything, statistics, research methodology, but the purpose is not to discuss too much of research methodology. So let us concentrate on inferential statistics. So somebody called me yesterday from, I think, CUK, Central University of Karnataka, that Motwani or someone.
Yes.
So she was trying to ask me about inferential statistics, and of course there are several topics we can handle in research methodology, but due to paucity of time, we are only picking one topic, that is inferential statistics. So now, before we get into inferential statistics, what do you mean by inferential statistics? What do you mean by inferential statistics? What is inferential statistics? Yes, please, any one of you. What is inferential statistics?
Rajesh, you can respond. Somebody can respond.
Inferential statistics.
You are a
So, if it is inferential statistics, what is?
Huh?
Yes.
How statistics can be classified? How statistics can be classified? Statistics can be classified broadly into two parts. One is descriptive statistics, second one is inferential statistics. The descriptive statistics deals with describing the data. For example, you have 34 people, that is one description. Out of that, so many girls, so many boys, that is another description. So many are scholars, so many are faculty, another description. So and so from Mysore, so and so from Dharwad, so and so from Bijapur, so and so from Gulbarga, that is another description. And another description is, you are into economics, you are into sociology, you are into political science, you are into management, you are into commerce. This is another dimension. Then your marital status, that is also a kind of a description. Quantitative data, that is quantitative data. Marital status, or maybe age of the individual, experience, and academic credentials, your marks in 10th class, marks in plus 2, marks in graduation, marks in post-graduation, and whether you qualified NET or not. Yes, no. How many papers you have published so far, how many research methodology workshops you have attended so far, whether you have completed coursework or not. So if I keep on asking these kind of questions, and output of these questions, either they may be qualitative, they may be quantitative. The quantitative means age is a quantitative, income is a quantitative, height is a quantitative, weight is a quantitative. Then the distance between your native place to Dharwad is a quantitative, and your salary is quantitative. And qualitative is your gender is qualitative, marital status is qualitative, social background is qualitative, religion is a qualitative. Then qualified NET or not is a qualitative, and the subject which you are studying, that is also qualitative, right? So, are you smoker or not is a qualitative, are you alcoholic or not is a qualitative. Then this is how we look at the data, qualitative data and quantitative data. But with the help of this quantitative and qualitative data, if I start explaining about your group, that becomes descriptive statistics. And there, whatever quantitative data we have, for example, you have 34 people sitting here, that is a quantitative data. Then what is that, I can draw a conclusion from there. Dr. Brahmanandam said there are 34 participants in the group. So what is the conclusion I can make out of it? It is too big, it is too small. What is my assessment? How do you understand? 34 is the number of participants attending this workshop. So what does it mean? What kind of a conclusion I can draw from there? Is it big, is small, is reasonably good, reasonably bad? What do you think of?
Respond.
Sir, I think
Yes,
the
please.
data is too small for intention, but it is better to be explored for the descriptive analysis.
Okay, so one argument is I am not getting into data analysis. I am only having some opinion about the data. That's 34. So now this can be said better. In the last program, when we conducted similar program, there were 60 participants. Or last time when we conducted the program, it was 20 participants. Last time when we conducted 10 programs, the maximum participation is 60, minimum participation is 20. So if I keep on giving you this kind of extra information, you will have a better understanding of the data. Yes or no?
Yes, sir.
Yes. And I'll go one step further. Instead of going for the maximum value of last 10 workshops, minimum value of last 10 workshops, I can also now speak about the average attendance, average number of participants over a period of last 10 programs. So this is where descriptive statistics will come. And also I can speak about median, I can speak about mode, I can speak about geometric mean, I can speak about harmonic mean. All these 5 kinds of means are known as measures of central tendency. So, but I have 10 programs data with me, not one program. Then I would like to know that what is the minimum, what is the maximum. The difference between minimum and the maximum is known as range. Then I can go for mean deviation, I can go for quartile deviation, I can go for standard deviation. So these are the measures of dispersion. So measures of central tendency and measures of dispersion are part of descriptive statistics. Okay, descriptive statistics. Let me open my Excel file. Are you able to see the Excel file? Yes or no?
No, sir.
No?
No, sir.
Okay, 1 minute. Okay. Now?
Yes, sir.
Okay. So now, this is program 1. This is program 2. Like that, I will take 10 programs. 10 programs. The attendees number 24, 28, 45, 32, 38, 56, 62, 29, 27, and you are 34. You are 34. This is current program. 10 is the current program. This is the current program. Now this is the data we have. This is the descriptive data we have. Okay. So this is the data. Now P1, P2, P3, P4, P1, P2, P3, P4 stands for program. So when we have this 10 programs data with me, the last program is 24. Now tell me what kind of analysis you can do on this data. What kind of analysis you can do on this data? Yes, madam? Mean,
Mean is just.
median, mode, then range. Then there are several things you can do. Standard deviation. Or if you want, I can also say something about skewness of the data. So if I wanted to get the mean, don't worry about the formulas, just you can use only this Excel. So this is mean, average of B1 to B10, 37.5. Median, mode, why N by A for mode?
There is no repetition of the data.
There is no?
Repetition of the data. Same number of.
Okay, now I made repetition, 28. Okay, range, maximum of, range is now will not have a direct function, maximum minus minimum. Maximum minus minimum. 38. Maximum minus minimum. Or if you click here, you can see the minimum value, maximum value. Minimum 24, maximum 62. The difference is 38. Sum is 374. Count is 10. Average is 37.4. You can see without even using any formula, you can get here. Then standard deviation, STDEV. So we have so many decimals, so I wanted to reduce them. Skewness. Skewness. Again, I am going to reduce this. Okay? Is it clear now?
Yes, sir.
Is it clear now?
Yes, sir.
Yeah. If you have any difficulty in doing all these things, straight away what I can do now, you can go to data. There is something called data here. Okay? Data. So in data, we have something called data analysis here. Data analysis. You open that. Descriptive statistics. This is a function of this is a tab. Descriptive statistics. Input range. Okay. Output range. So I wanted to have my output here. What do you want? Summary of statistics. Summary statistics. Click OK. The interestingly, you can get mean, median, mode, standard deviation, skewness. Very one simple function is going to help you all this instead of doing independently. Yeah. Now 37.40, 33, 28, 12.97, 1.04. Exactly matching. Minimum 24, maximum 62, sum 374. So the function what I have used is, here there is something called data. Data. In data, there is something called data analysis. Data analysis. So just you open and you do that, you get everything at one place. But now something is new to you, whatever now so far I said. I think this part I have not discussed. Then, of course, this part I have not discussed, but I think you will be knowing. What is the difference between standard deviation and variance?
Variance is called the standard deviation.
Standard deviation into standard deviation.
Square.
Yeah, you can see 168.27. This is called variance. So standard deviation square. Skewness 1.04. Range 38. Minimum, maximum, sum. And one more thing what I have not discussed is kurtosis. 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 Kurtosis speak about the bulginess of the distribution. So the data is classified into three parts. One is leptokurtic, mesokurtic, platykurtic. That speaks about bulginess or peakness of the distribution. So if kurtosis is less than 0, it is platykurtic. Platykurtic. Exactly 0, it is mesokurtic. More than 3, more than 0, that is leptokurtic. So this is one thing, kurtosis. Anyway, this is the data. This is the data. Okay. So with this data now we have given you all the descriptives. They are called descriptives. Whatever now I have computed here, they are called descriptives. The subject, the statistics which handles this descriptives is called descriptive statistics. Descriptive statistics. Okay. Which is going to handle these descriptives and make the analysis and make the meaningful interpretations. Okay. The next issue is, you are all from social sciences. I'll take you to some data which already I have collected. So this is some data. This is some employee data. So employee code is there, gender is there, age of the employee is there, current salary is there. Then I think I can delete, I can hide this. Yeah. So because gender is already there. Education level, how many years they have studied, 15 years, 16 years, 7, 12 years. Beginning salary, 27,000, 18,750. Months since hired, that means experience, job experience. Previous experience, before joining this organization, what was their experience? Then promotability, whether is some employee is promotable, yes, no. If it is yes, 1, no, 0. Employment category is 1, 2, 3. There are 3 categories. This is the data. So you know what is the sample size? Sample size. So this is my population sample. 474. 400 and you can see 474 is my sample size. 474. So the population could be 10,000, 20,000, 15,000, whatever. From there, I've taken, when we are discussing about inferential statistics and descriptive statistics, you should also know something about sampling. So broadly, sampling is classified into 2 categories. One is probabilistic sampling, second one is non-probabilistic sampling. Under probabilistic sampling, we have simple random sampling, stratified random sampling, cluster random sampling, systematic random sampling, multi-stage random sampling. Non-probability sampling is judgment sampling, convenience sampling, quota sampling, snowball sampling. These are all sampling techniques. The biggest challenge in our social science research is, one is whether we should go for sample study or not. Number one. If you are going for sample study, what is your sample size? What is your sampling technique? What is your sample size? What is your sampling technique? And also, we are trying to know that what kind of data analysis tools I would like to use for my data analysis. What kind of data analysis tools I should use for my data analysis. These are the decisions you are supposed to make when you are going to do the research. So here my sample size is 474 and population is 10,000 or what. So my simple question is, what is the average age of my sample? This is column C, average age. What is average age? You can see. How much you could see here? Are you able to see? Here, this bottom, average. 34.02 is this bottom, average, here. Are you able to see this row? The average count, numerical count, minima, maxima, sum. Are you able to see that?
No, sir.
Average. Are you able to see the row
No,
at the bottom?
No, sir.
Are you able to see this? Yeah. But when I am zooming, only the cells are zooming, not the thing here. But here something is appearing. Average. Are you able to see the word average? Yeah. So that is 34.02. 34.02. So that is what it is. So now my question is whether this is sample. Sample. So here 34.03 with 027. So for example, I take this age and I'll put here. Okay, this is my data. This is my data. Okay, I delete even age. So this is my age, sample respondents age, 40, 32, 56, 37. So if I click this, the average is 34.02. But if I wanted to even check average, comma, A1 to A474, 474. A1 to A474. Yeah, 34.02. This is what is the average age. This is what I am calling as X bar. X bar is the sample mean. And small n, sample size is 474. X bar 34.03, n is equal to 474. Is it clear up to now?
Yes, sir.
Yes, no?
Yes, sir.
Now I am interested to know my capital N, that is population. Capital N is some 10,000. Capital N is 10,000. That is 10,000. So if you wanted to have comma, select this, put comma. Yeah, though you don't require decimals, you delete this. Yeah, 10,000. So now my question is, this is the sample mean, that is 34.03. That means in an organization, when there are 474 employees sample we have taken, the average age is 34.03. Now I would like to see whether mu, this is mu. What is the symbol for mu? No? How it looks like?
It's like this.
Insert. You can see insert. Insert. Okay, insert. Here, symbol. Yes, symbols here. Equation, symbol. Here you can see mu. Yeah, this is called mu. This is mu. Mu, that is Greek letter. That is the population mean. Mu is population mean. X bar is sample mean. Sample mean. Okay? Sample mean. This is population mean. Now my question is, based on this sample, 474, can I conclude that population mean is also 34? This is the question.
Certainly, sir, we can.
Yes, please.
Yes, we can presume.
Yeah, we don't know. That is what is the question now. How do we answer that question is through inferential statistics. That is what I wanted to drive. Because I have only the sample data, 474. I don't have this 4,000 persons data, 10,000 persons data. I don't have this 10,000 persons data, but though they are not there, the data is not available. But now, based on the sample data, 34.03, now I would like to test the hypothesis whether population mean is also 34.03. Got my point?
Yes, sir.
Yes, no?
Yes, sir.
For which what I am now trying to do, H naught. H naught. H naught. Copy. Select this. Mu1 is equal to 34.03. This is what is called? This is called what? Null hypothesis. H stands for hypothesis, 0 stands for null. Null hypothesis. So my assumption is my population mean is equal to sample mean. Got it?
Yes, sir.
Yes, no?
Yes, sir.
Now I am pasting here, I am saying this H naught, I am saying H1. This is alternate hypothesis. Mu1 is not equal to, this is the symbol we use in Excel, not equal to. The symbol is this. Not equal to symbol is this. H1 is to mu1 is not equal to 34.03. So otherwise, how do you say this? What is the general form of not equal to? How do you say?
Greater than,
Greater
less
than,
than,
less than.
You put you put is equal. Then you have to strike this, right?
Yes, sir.
So for example, I wanted to have a symbol for not equal to, okay? Symbol for not equal to, okay? So that's what just I am searching for symbol for not equal to in the Google. Yeah, symbol for not equal to into Google. So if you do that, you will get the image of unequal to. Okay, let me show you that symbol for your understanding. All of you must be knowing, but still I am showing. Yes. So you can see this, the symbol. Yeah, I think I've been able to show you, but you know, not equal to symbol. Okay, anyway. So now this is the question. I need to test the hypothesis whether this is not equal to, this is the symbol, not equal to 34.03. So I need to test this hypothesis. So this process actually is done through inferential statistics. H0 is to mu1 is equal to 34.03, H1 is to mu1 is not equal to 34.03. So how do I check this hypothesis? Okay. So for which I do one thing, I will take you to SPSS, because you know the testing of hypothesis, because I can also show you in Excel, but Excel is a little cumbersome process. I will take you to SPSS. SPSS I will take you now. Yeah, just give me a minute. SPSS. SPSS. SPSS, you know, I am opening. You know what is the full form of SPSS?
Statistical package for social science.
Statistical package for social sciences. Statistical package for social sciences. Statistical package for social sciences. So now I would like to take that particular data, whatever data I have here. So this is my data set. This is my data set. I am copying this data. I am copying this data. I copy this data. So I will take you to SPSS, but it is taking more time than required. I will show you here SPSS.
Excuse me, sir.
Yes, please.
So the SPSS screen is not visible yet.
SPSS?
Screen is not visible yet.
Yeah, no, I'm trying to open that file. Yeah, I'm trying to open that file. Let me just give me 1 minute time. Yes, I'll open that. I'll open that file and show you. One minute. Okay. SPSS. Yeah. SPSS. Is it open now? Not yet, okay. Yeah, it is now opening now. So let me show you. So just I open that SPSS file. Yeah, there is some issue with the SPSS file. Otherwise, I will show you in Excel only. There is no option. I will show you in Excel. Some license is expired and it is not renewed. Okay. Program files. IBA. Anyway, so there is some problem. I never thought of showing you. Just let me show you that, and that's what I thought, but it is not working out. Okay, fine. So let me go to Excel only. So this is my data. Are you able to see the Excel file? Yes or no?
Yes, sir.
Okay. So this is my data, and mu1 is equal to 34.03, mu1 is not equal to 34.03, and your sample size is 474. So what do I require now? Sample standard deviation. Yes, sample standard deviation. So for which STDEV, A1 to A474. That is the data. So this is my standard deviation, 7.42. Yes. Okay. I require something called standard error. I'll tell you what is the standard error. But otherwise, the Excel itself can compute the standard error. If you want, I can show you that also. Say for example, data. Here data. So data analysis, data analysis, descriptive statistics. So my data is from A1 to A474. Output range is somewhere here I am saying okay. Now you can see that I got this standard error is equal to 0.3409. Got it? From here, standard error 0.3434, yeah, 0.341. So how did I get the standard error? Anybody can tell me? How did I get this answer? 0.341. Any idea? Of course, I got from Excel output. But if I wanted to physically compute, how do I compute? That is equal standard deviation by square root of sample size, 474. You can see. Got the same answer? Same answer? Yes or no?
Yes, sir.
So now the standard error is S by square root of sample size. This is the formula. S is the sample standard deviation and square root of n. S by square root of n. S by square root of n. Otherwise, straight away you can get from this. And here also you can see the mean. Already we have computed, but of course still I can show you the mean. 34.027, 0.34.03. So still, my question is like this, the sample mean is 34.03. So I am testing the hypothesis that my population mean is 34.03 or not. So one null hypothesis says yes, alternate hypothesis says it is not. S is equal to 7.42, standard error is equal to 0.341. Then I'll calculate something called Z value. Z. Z is equal, any idea? X bar. X bar.
Minus X divided by
X bar. X bar. X bar. 34.03. 34.03 minus mu. Mu value, for example, some 36. I will tell you why. By standard error. So here I am saying, though my sample mean is 34, I am actually thinking that whether it is 36 or not. It is 36 or not. I am testing whether it is 36 or not. Now I got 34.03, but still 34.03 I can consider 36 or not. So this is what is Z value. This is called Z calculated. So there is something called Z table value from the normal distribution table. You know that normal distribution table?
yes, sir.
Yeah, normal distribution table. Z table. For 5% level of significance, 5% level of significance, the answer is 1.96. 1.96 plus or minus. Plus or minus. Plus or minus. Plus or minus. It is not accepting this hyphen. Yeah. So what I see now? Plus or minus 1.96. Oh, it is taking, when I say plus, it is taking is equal to automatically by default. Okay. So now it is 1.96. So how the normal distribution looks like? You know? How the normal distribution curve looks like? Bell shape, right. So it is okay. File, new, don't save. Okay, you take a pen. Are you able to see the paint? No. Are you able to see the paint? No. This is the problem with the Zoom. In the Google, whatever operations we do, we are able to show. But now every time we have to stop sharing this and again go for a fresh sharing. Okay. Now I am sharing again. So now I think I am going to do that. So, for example, if I take, are you able to see this thing?
Yes, sir.
The paint, are you able to see?
Yes, sir.
Why I am getting this design in the paint? It's a puzzle. New, don't say. Wait. Okay, now I am going to draw the normal curve. This is the straight line. This is like this, right? So now this is the rejection zone.
Yes.
Minus 1.96. Here it is plus 1.96. But my calculated value is 5.78. So 5.78 is minus 5.78. This is minus 5.78. So this is rejection. This is rejection. This is do not reject. So minus 5.78 is reject. So now you go to null hypothesis. Null hypothesis says stop sharing. Again I have to share. Yeah. So are you able to see this Excel sheet now? Yes, excellent. So now you can say reject null hypothesis. Reject null hypothesis. Reject null hypothesis. So you are rejecting null hypothesis. That means this is rejected. It is not 36. You are thinking it is 36, it is not 36. So it is not equal to 36. But definitely it is not more than 36. You can say because 34 is less than 36. Now you can say that population mean is less than 36. This is the conclusion we are making. Got it?
Yes, sir.
Yeah, this is the thing, what we are going to do in hypothesis testing. Just, before getting into the whole concept of theory, so I am just giving you some kind of a brief. But this 1.96, whatever I got, is the table value for 5% level of so if I put the process of 5% of the time, I may be wrong. 5% it is 1.96. Okay. If it is 1%, 1%, 2.58. If it is 5%, 1.96. If it is 10%, level of significance, 1.65. Actually, these are table values, but you can even by heart these three also. 1.65, 1.96, 2.58. So in social science research, by default we take 5% level of significance. By default, we take 5% level of significance. So that is where I took 1.96. Is it clear now?
Yes, sir.
Clear?
Yes, sir.
Okay. Now, I'll stop this is what I think I wanted to give you gist of testing of hypothesis, but let us get into the theory behind this. Yeah. Okay. So again I have to stop sharing this. Okay. And now are you able to see the PowerPoint now?
Not yes, sir.
Yes or no?
Yes, sir.
Okay, fine. So if you see this, what is inferential statistics? The inferential statistics is generalized from samples to populations, hypothesis testing, relationships among variables, uses sample data to evaluate the credibility of a hypothesis about a population. That's what I have done. So once you have the sample data, we are trying to generalize to the populations, or to test the hypothesis, or to find out the relationship among the variables, or uses sample data to evaluate the credibility of a hypothesis about a population. So that is what is nothing but hypothesis testing. Hypothesis testing. So in hypothesis testing, actually, this is what happens. Sample data to evaluate the credibility of a hypothesis about a population.
Statistics ಎರಡು ಕಲಿತಿದ್ದೀನಿ ಒಂದು ಸೆಮಿಸ್ಟರ್
Sir, some net problem? Oh, sir. Okay, sir. Thank you. There he is. So he is getting connected. He is using his own net. No. University suddenly power get shut down.
Economics. What is different in the budgets? We can just sit in here. Monday the office concept, not internet work. Okay. Kashay break. ನಾವು ಮಾಡ್ಕೊಂಡು ಬರಬೇಕು.
Yeah. Sorry, just
Yes, sir.
I lost that one. Now, one thing happened in between is that I was able to connect my SPSS. Yeah, that's what I could do now simultaneously. Now, are you able to see the SPSS sheet?
Yes, sir.
Yes, no.
Yes, sir.
Yes, no.
Yes,
Yes,
sir.
Okay. You are able to see this, right? Okay. Okay. Now what did I do is I have pasted this data. Are you able to see the data?
Yes, sir.
Yes, no?
Yes, sir.
Fine. So here I would like to analyze this data. Analyze here. Compare means. Here interestingly in SPSS there is no Z test. It is only T test. Again there is a logic behind it because usually while teaching statistics we say T test is used for small samples, Z test is used for large samples. But as the sample size increases, T distribution approximates to Z distribution. So that is the reason why what they are thinking, what they are doing is they are only doing the T test. There is no that here. One sample T test. So here I will do that. Then the test value I was testing for 36. Just I click. Have you got the output table? Have you got the output?
No, sir.
Yes, no?
No.
No, sir.
Again I have to stop this and show the output file. Okay. Yeah, now you can see the output file.
Yes, sir.
It says, T test, N value 474, mean 34.02, standard deviation 7.42, standard error is 0.34. T value, that's what I got, minus 5.78.
Yes, sir.
Yes, no. T value, same value we got earlier. Yeah. So significance is 0.000. So that means, this value is known as P value, P for probability. If it is less than 0.05, reject null hypothesis, because that 5% is level of significance. So this is a little different form from earlier one. The earlier one is we are comparing with the Z value of the calculated Z value table. But here we are looking at the P value, this is P value. So this P value you are trying to look at whether it is less than 0.05, more than 0.05. If it is less than 0.05, reject null hypothesis. That means it is not 34.03. That is the conclusion. It is less than 36. It is not 36. It is less than 36. This is the conclusion. Is it clear now?
Yes.
Is it clear?
Yes, sir.
The advantage of SPSS is you need not compute mean, you need not compute standard error, you need not compute t value. Straight away you are going to get the answer. Straight away you are going to get the answer by like this. Okay. So I will just, before I close SPSS, I will show you one more thing from my Excel data. So stop sharing. Stop sharing. Again I shared the screen. So let me see. This is my data file, Excel file. Sorry. Stop sharing. Again I have to share. Yes. Now you would like to see one more issue I would like to show you. We have current salary and we have beginning salary. These two salaries I have, current salary and beginning salary. Now I would like to see whether there is a difference between current salary and beginning salary. Null hypothesis says there is no difference. Alternate hypothesis says there is a difference. Null hypothesis says there is no difference. Alternate hypothesis says there is a difference. So again, H0 is mu1 is equal to mu2. What is this mu1 and mu2? Mu1 is the population of current salary. Mu2 is the population of the beginning salary. So alternate hypothesis says both are not equal. Mu1 is not equal to mu2. Alpha is equal to 5%. This is the data we have. For which we are testing the hypothesis whether there is a difference between beginning salary and current salary. Or in a simple sense, I can say, for example, today morning I am discussing with you this inferential statistics. Before starting the session, if I conduct a test on inferential statistics, you get some scores. After my class, if I conduct the test again, you get some scores. So I would like to test the hypothesis whether there is some improvement in your performance or not before and after the class. For which we use paired t-test. Paired t-test. Paired t-test. For which again what I am trying to do now, I copy this data and paste here, paste here, paste here, paste here. Vijayanakshi. Unna. A51. చిన్న గేట్ అంటే మసీద్ బండ గేట్ గోపనపల్లి సైడ్ రావాలి అంటే నెక్స్ట్ సైడ్ రావాలి కానీ విత్ ఇన్ ద క్యాంపస్ సైడ్ మెయిన్ గేట్ నుంచి అడుగు చిన్న అటు గోపన సౌత్ క్యాంప్ సౌత్ క్యాంపస్ గేట్ దగ్గర A51 క్వార్టర్ పెడతా సారీ. సో నౌ we have this current salary and the beginning salary, current salary and the beginning salary. So now I wanted to test the hypothesis, current and beginning. So before I go for Excel, SPSS, I will show you in Excel also. So here home, I have data, data analysis. Here data analysis, we have something called t-test paired to sample for means. T-test paired to sample for means. So now, if you do that, the current thing is A1 to A475. Why I am writing 475? Earlier I was writing 474. Why I am writing 475 now? Any idea?
First row is what indicated. Current salary.
Yeah. In the similar way, here I will say B1 to
B475.
475. Labels in the first row. Labels in the first row. Your output you are going to say here. And if I click OK, I get the output. You can see now, very interesting output I am getting. So here, if you look at this, mean salary, mean salary, this is my mean salary, 34,420. My beginning salary, 17,000. Obviously there is a difference, 17,000, 34. There is no need to test hypothesis. When the difference is very narrow, say for the 34,000, 33,000, 34,000, 35,000. So in the sample I am finding 1,000 difference. When I am generalizing to the population, whether this 1,000 difference is sufficient enough to say there is a difference exists in the population or not. This is the question. So for which I have done it. So you can see the p-value. Yeah, this is what it is, a p-value. What is p-value you can see? 8.05 into 10 power minus 134. That means 0.00000. That means it is less than 0.05. So that means reject null hypothesis. So what is null hypothesis? Both the population means are same. But no, now it rejected. That means there is a difference between beginning salary, current salary. Or there is a difference between the before and after. So for example, before exercise, after exercise. Before food, after food. Before coaching, after coaching. Before training, after training. Before maybe promotion, after promotion. Before job, after job. If whatever I want, I can. Before hypertension, after hypertension. Before cardiac surgery, after cardiac surgery. I take 2 samples and whether is there a difference between their efficiency, their energy, their competencies, their fasting blood sugar, whatever you want, you can test. Their creatine levels or anything. Their satisfaction scores before and after. So this is what, the interesting part is, with Excel, without using any formula, simply by using this data analysis, I was able to show you this. This is called a paired t-test. So paired t-test. So here, I would like to select this data, copy, and again, I close this, and I share, I go to my SPSS. So here I know I am going to paste. So this I delete. Oh, clear. Yeah. This I clear. So here one is beginning salary. This current salary, beginning salary. Here I have to type. Unlike Excel I was typing in the first row. But in SPSS we have another sheet. Variable view, data view. The variable view says here it is current salary. Current. Now you see now data view here, yeah, current has come here. Then here again beginning salary. Beginning salary. You can see now beginning salary. But the data is nominal. Nominal means numbers, not numbers, names. But I have to change nominal to, yeah, it is string. It is not string, it is numeric. It is a string, it is not a string, it is numeric. So now if you take this data, it is scale data. Is ordinal, nominal, no. Now you can see now, this is current and beginning. So for which now I wanted to test the hypothesis, analyze, compare means, independent sample, summary, paired sample t-test. You can see paired sample t-test. So it says current salary here, beginning salary here, current salary, beginning salary, yeah, beginning salary, okay, current salary, beginning salary. If I say okay, then again I have to go to output, again output file, this out, yeah, here it is output file. You can see the output file now. Are you seeing output file?
Yes, sir.
Yeah, mean is given is here, 34,419, beginning salary 17,000, 474, 474, standard deviation, standard error, then paired. The correlation between these two also computed, 0.880 and minus 5.786, this is one sample, sorry, here, actually, paired sample, yeah. Current is 34,419, beginning 17,000 and N 474, and you can see this. Where is this? Yeah. Now you can see this, 474, 474. Mean difference is 17,403. The p value, you look at 0.000. That's what I got several zeros now. Same thing. So it is less than 0.05. So reject null hypothesis. Is it clear?
Yes,
Yes, sir.
Yeah, now the paired t-test also we can do by using Excel and SPSS. So I'll now stop this Excel and SPSS business. Now straight away now I will take you to my PowerPoint and quickly do something about hypothesis testing quickly, and we will see. So this is what is inferential statistics. Okay. So now there are two things in this inferential statistics we need to understand. One is statistic, second one is parameter. The statistic is a descriptive of a sample. Mean, median, mode. This is of the sample. Mean of the sample, median of the sample, mode of the sample. That is descriptive of a sample, that is statistic, and descriptive of a population, that is parameter. Population mean, population standard deviation, population median, population mode, whatever related to population, that is called parameter. So what exactly happening in inferential statistics is, given the sample statistic, we are making the judgment about the parameter, or we are drawing the inference about the population, we are drawing the inference about the parameter, we are making estimation of the parameter. So given the statistic, you are estimating the parameter. Given the statistic, you are drawing the inferences about the population, statistic and parameter. So there is something called sampling error. The sampling error is variability between sample mean and population mean. Sample mean and population mean. So this is what is the sampling error. So that means the whole idea is, we wanted to do that something about estimation of the population parameter. But here, we are trying to look at when you are estimating the some sample population mean. But population mean is something, but I am drawing a sample. So the difference between population mean and sample mean is the standard error. Say for example, again I will go to Excel sheet and will show you once again what is this sampling error. So here, let me share my Excel sheet. So this is my Excel sheet. Where is my sample age? Earlier we had my age. Where is the age? Yeah, this is my age. Copy. So this is my age. Are you able to see this Excel?
Yes, sir.
Yes, no?
Yes, sir.
Yeah. So this is capital N. Now I am considering, earlier I said this is my sample. Now I am considering this is my population. Now I wanted to draw 50 sample from this 474. That means 50 persons age I would like to compute, and I would like to see what is the sampling error. If I sample mean X bar, I wanted to know X bar. And also I wanted to know mu. Mu is population mean. So if I select this column, the population mean is 34.03. That already we have computed. 34.03. But I wanted to draw 50 sample from 474. How do I draw 50 sample from 474?
I think random samples can be drawn.
Random sample. So for which what I do now, I go to again data. Data analysis here. Go for sampling. The sampling is here. So your input range is A12 because there is no heading. 474. The random sample of 50 units you want. Where is the output you wanted to get? I wanted to get my output here. Yeah, this is my sample. So you can see now B1, B2, B3, B4, B5, B6. Yeah, up to 50. It has randomly selected 50 items from 474. Remember, randomly it has selected 50 items from 474 items. So if I select this 35.42, 35.42. You select this 35.42. Now, sampling error. Sampling error is equal to 35 minus 34. 1.39. This is what is called sampling error. Got it?
Yes.
This is what is called sampling error. So, the difference between sample mean and population mean. And also you got the technique of drawing the sample by using Excel, where you have a population of some 20,000, 30,000, how to draw a random sample of 50 units or 100 units. Now I have shown you the procedure. This is how you are going to draw the sample. So, I have told you two things. One is sampling error, second one is standard error. Now you tell me what is the formula I said for standard error?
Standard deviation divided by
Yeah. This is what I think you know, sampling error and standard error. Sampling error is the difference between population mean and sample mean. Standard error is, the actual standard error is mathematically, of course, we are saying that standard deviation by square root of n, but actually it is standard deviation of sample means. Standard deviation of sample mean. That means when I am drawing 10 samples, 20 samples, right now I draw one sample of 50. Right. So let me show you that also. If I select here, so this is the first sample. Now here I will insert. So I say this is population. And this I say S1, sample 1. And if I say S2, if I say S3, what is S1, S2, S3? Samples. But by any chance, if I draw the second sample, I get a different sample. Yeah, I get a different sample. Second sample, I am going to get the different one. So here, if you look at sample 2, so again, data analysis, sampling. Okay. Yeah, instead of A1 is because of heading A2 to 475 because A1 is a text data was there, that's what it is conveying. Okay. Second. The third one, again, third sample, data analysis. Okay. Now here I say D2. Okay. I got the third sample. Now I am going for fourth sample. Fourth sample. This is E2. Yeah, last sample I am going to take. Okay. F, now F. Yeah. These are the samples, right? So these are different samples. Every time we are getting a different sample. Now I calculate the mean, average of B2 to B51 because of the heading. Yeah, 35.42. If I drag this, I get 35.42, 33.52, 35.14, 33.38, 33.38. Though the samples are different, I got the same mean. You can see. Now, standard deviation of select this file. 0.913683. This is what is standard error. Now if you look at here standard error, how much standard error we had? Population?
1.
Yeah, standard error. You can see this standard error. Standard error. Sheet 1, sheet 2, yeah. Standard error. Mean standard error, you can see. 0.341. This is standard error. But we have taken only 5 samples. If you take 10 samples, 20 samples, 30 samples, 40 samples, we are going to get that value, the right value. So this is point, but this is approximate because in the real life situation, we may not be able to take these many samples. We do our research with a single sample, not multiple samples. So that is where we are using this approximation of S by square root of n, standard deviation by square root of n, we are going to use. But otherwise, if you take so many samples, I have only tried this file. If I take 10, 15, 20, 30, 40 samples, take the standard deviation of sample means. Standard deviation of sample means. So that is going to be standard error. Standard error. Okay. So now it is 11:04. I think you must be having the second session. So I will stop here and I would like to quickly take some 2-3 questions based on whatever we have discussed. Any questions if you have, just please ask me because giving inferential statistics in 1.5 hours would be very difficult. Had I started the presentation, I would have been discussing with you type 1 error, type 2 error, left time test, right time test and so many things and formulas and other things, you would have got bored. That's where I have shown you how it is to be done. But I will stop here and I will take 1 or 2 questions before I wind up. Thank you. Please.
Any questions, please?
Sir, I have a question here. In case of calculating studies through SPSS, if the sample is more than 30, then as we have taken the sample of 474 here, so rather...
Yeah, now by default you can go for a t-test independent of the sample size.
T-test independent.
T-test only, by default. Small sample, large sample, because when the sample size increases, t approximates to z. So everything interpretation is made with the z values only. So you simply use only t-test. Only the statistics class only we discuss z-test. But when actually you are doing research, you would be only using the t-test.
Okay, sir.
Use t-test only.
And the value of the t-test from the normal table, we have to take the value of
Yes, madam. T-table.
Yes, sir.
If you do manually, you have to take t-table. But if you use SPSS or Excel, there is no need. Automatically table values are computed. Straight away. You have to see only p value.
Sir,
Whether it is less than 0.05, more than 0.05.
So definitely it would be justifiable to use T in spite of Z-test in case of large number of samples.
No, actually Z-test, Z-test was a kind of a, before t-test was developed, Z-test was very popular. See, Z-test is only for large sample, not for small sample. T-test is universal for small and large. That is the reason why we are only saying T. The latest softwares will have only t-test, no Z-test.
Right. Thank you, sir.
T is universal. T is universal for small and large. You just forget about Z in research. In research, you forget about Z. You only use Z-test somewhere, standardize the normal score. When you wanted to standardize the normal score, then only we use the Z value. But otherwise, hardly we use Z. Only we use t-test.
Hello, sir.
Yes, please.
Sir, population mean is unknown. We use automatically t-test.
Population.
Mean is unknown. We use t-test when sample size is big or not.
No, even we are not debating between Z and T. That was all old notation. The old notation says when the sample size is less than 30, go for a t-test, more than 30, Z-test. That was one. The second one is when the population standard deviation is known, go for Z-test. If it is not known, go for t-test. That was the earlier traditional classical way of classification. But now the latest things are just ignore that and only do t-test, and it will automatically take care of a small sample or large sample. If you take a t table, it will give you the table values up to 1 to 30, 1 to 30, 1 to 40 or 1 to 50. Beyond that they put infinity and they will give Z values 1.96, 1.65, 2.58. What does it mean now? Even if the large sample you are using t-test, it is comparing the calculated values with Z values only. 1.96, 1.65, 2.58. That is the reason why you forget about Z. When you do manually only, we speak about Z. Otherwise, it is only t-test.
Good morning, sir.
Clear? Yes.
I had one general question.
Hmm.
Sir, you have completed 3 PhDs, I guess. I just wanted to ask, what was the inspiration you had and the motivation from you with respect to having completed that 3?
Very simple. Number one is multidisciplinary. Okay.
Sir, network problem I think. Some network problem, sir?
I'm a career counselor. I'm running a career counselor column. So I've been asking people, lot of people are coming to me for career questions. In the process, they are bringing lot of emotional issues. To address their issues, I started studying psychology subject. Then I have done my MSc psychology. Then I developed interest more in psychology, did PhD in industrial and organizational psychology. Again, it is connected to management. To 14 department.
Yes,
The department, I have qualification technology. Then, especially during COVID and post-COVID, so I had a problem that the current generation students, I am having a lot of problem in handling them, especially engaging them in the class, student engagement in higher education system. So then I thought, I wanted to make a study of how to engage students. That is what on student engagement and teacher engagement, student satisfaction, teacher satisfaction. Then I developed interest in that and I did PhD in education. Because we are in education, that is where I am into education. We are in education field and the psychology and education management are interconnected. So that is where I have connected these 3. Because of my engineering training, civil engineering training and mathematics training, I am more into quants and numbers. So now, today, what NEP 2020 is saying about multidisciplinary education. So they were saying about simultaneously you can do multidisciplinary education. Multidisciplinary education. So, and learn third actually started on it.
Yes, sir.
Nowadays, admission into BITS Pilani online MTech program in data science. So because big data, data science is going to rule the future. So as a teacher, unless we update, unless we get into big data, unless we get into this, there is no future. So I wanted to be relevant till my retirement, post my retirement. So I wanted to continuously update my knowledge with the latest developments in the field. So that's where I've been, my age is 53 now. So almost 44 years I have been studying from my first class to 3 PhDs. This is what is my motivation. Thank you.
Sure, sir. It was
Yeah, please.
Sir, we are highly grateful.
Anything more?
No, she is just I requested one of the participants to give vote of thanks to you, sir.
Okay, thank you. Carry on. Yeah, actually I know that I should have done more because 1.5 hours is nothing for me. And it being a physical session morning to evening, if I take 4 sessions, by the end of the day you would have become masters in this particular topic. But we will find some other opportunity to visit because my schedule is too tight and coordinator Brahmanandam approaching me in the last minute. Actually I would have said no. I would not say no to Brahmanandam because he has been requesting me for a long time. But especially for this program, it's very short notice. Otherwise, my schedules are totally I think, tied up.
Certainly, we
Definitely.
give you, next program we will give you, sir.
Yeah, some other programs somewhere, definitely we will be meeting. And
Sir.
this kind of things we should be doing offline. That would be more better.
Yes, sir.
When I come for this kind of programs, I do lot of motivation to publish good papers and a lot of things I would have done. Anyway, all the best. Yeah, thank you. Carry on.
So we are highly grateful to have you here in CMDR to have a session. Sir, I'm the one who pursued you for the session. Sir, on behalf of CMDR and all the fellow participants, I would like to propose you the vote of thanks. We are highly grateful and you really broaden our knowledge base on inferential statistics. Thanks a lot, sir.
Thank you, sir. Thank you so much once again.
Yeah, thank you, Pramananda. All the best.
Thank you, sir.
Yeah, see you sometime later.
Yes, sir.
Okay, thank you.
We'll
Bye
bring
bye.
30.
All the best. Yeah.
Yes, sir. Thank
all
you,
the
sir.
scholars and all the participants, you have my credentials. Just if you have any issue, just you can WhatsApp me or you can call me.
Yeah, that is what I wanted. If anybody wanted further reference or information, kindly help them, sir, please. This is what my submission to you, sir.
Yeah, sure. I'll do that. Yeah, I'll do that. Thank you.
Thank you.